Now we will try to understand how we can implement a queue or a FIFO data structure utilizing an array. So here we are going to understand two different operations in a queue, that is how to insert and how to delete a data item in a queue. And here also you have to follow some terminology convention. So whenever you want to enter a data item in a FIFO queue data structure, you call it enqueue, and whenever you want to delete a data item from the FIFO queue data structure, call it dequeue. So now let us try to understand how to implement the queue using an array. Now whenever it comes to the implementation of a queue, always remember this right hand side picture which is shown here. Why this picture is so important? Always remember that in order to maintain a long queue like this customer queue, you have to have two different receptionists. The first one is a rear receptionist who basically keep track of the growth of the queue, and then the second one is the front receptionist who is basically serving the customer in the beginning and take that customer out from the queue. So we will so this rear receptionist is actually being helpful in the enqueuing operation when the customer or data item is entering the queue, and the front or head receptionist is helpful when we are trying to delete a customer or dequeue an item from the queue. So now this thing can be easily implemented in a programmatically by utilizing two different variables, the front variable for this front receptionist and a rear variable for the rear receptionist. Now this entire place where the customers are standing, that can be easily implemented using an empty array in a program just like this. So here A is an array which is an basically an empty array. So now we have initialized this front and rear both to 0 in the beginning. Why? Just try to visualize what happens when the queue is about to begin, before the beginning of the queue, before any customer came. Before any customer came in the queue, both rear and front receptionist, they wait in the same place, that is in the beginning of the queue, right? So that's why we have just initialized both of them to 0 to indicate the first place in our empty array. So here actually both this rear and front both are initialized to 0 like this. Now the actual enqueue operation, you can see it in this else part. So what we need to do is, whenever you get a data item, you have to insert it in the queue. That is, let's say my data item, first data item is 000, some number or anything it can be. It can be floating point number, character, whatever. So let's say my first item is 000. So if I want to insert that or enqueue that in the queue, first enter it a rear, that is A0. So I am inserting 000 in this queue, in this empty array. And then what I am doing is I am incrementing this rear variable like this. So from rear equals 0, rear will be incremented, and now its value becomes 1, like in here. So that's how the first element have been enqueued in the queue. It is just like the fact that after entering the first customer in the queue, the rear or tail receptionist is waiting on the customer's back to manage the queue. Simply like that. That always happen in the real world scenario. Just enter a customer and then wait in the back of that customer so that you can serve the other one. So that's what we are exactly doing in here. Enter 000 and increment rear by 1. Next time when the next data item comes or the customer enters, what will happen? Let's say the next data item is 111. So I put it in the empty array or our queue, and then just increment the rear once again. So this time rear becomes rear plus plus, so it becomes 2. So now what will happen? So again rear is implemented, so the next item have been inserted or enqueued in the queue. When the next item comes, again the same step. Let's say the next item is 222. I inserted it, and then I incremented the rear by 1. Then again, so rear equals 3. And finally, next when the next data item will come, then let's say it is 333. I inserted it, and also I incremented this rear plus plus, and now its value is 4. Now I have realized that all right, my queue is, or the empty array, the capacity of my entire array is reached. I cannot hold any more element. So at that time we call that okay, the queue is full and you cannot enter a new item. It is just like the case that, well, the restaurant cannot serve any more customer. So that's the enqueue operation in a queue. Now let us try to understand what happens during dequeue operation. So here once again, queue is a FIFO data structure. So the customer, this one, or the data item in here that came first, that should be eliminated first also. So here actually this front variable comes into picture. So what you need to do, this else part, basically this two line of this else part here, this dequeued item and these two lines basically shows you the algorithm for dequeuing an item. So what I am doing is, first I am saving the item in a variable called dequeued item equals a front. So let's just remove this item. I saved it in dequeued item, and then I am incrementing the front variable by 1. So now instead of 0, now the value of front is front plus plus, that is equals 1. So 0 is eliminated and front is incremented to 1. So now your queue is basically from this element from index 1 to index 3, like this. So next time whenever you want to delete or dequeue another item, you take that out first, that is 111 will be deleted, and then increment the front by 1 once again. So now front is 2. Next time again same, just delete 222 and increment front, and front will be front plus plus, that is 3 now. And finally when you delete this element, this 333 is also deleted, and using the same logic front is incremented. So now the value of front is front plus plus, that is equals 4. Now as you can see, whenever this value of front and rear both becomes equal, non-zero equal number, then you can tell that alright, there is no other element in the queue. The queue is empty and there is nothing to remove from the queue. So that's how you can do the dequeue operation in a queue. However, there is a point of inefficiency when it comes to an array implementation of queue, of this dequeue operation, which is this part. So what is the inefficiency is, if you can remember the array, you can easily recollect the fact that whenever I want to delete an element, delete the front element of the array, you have to shift all the other element in the array by one room. So starting from index 1, if you want to delete the element at index 0, you have to shift all the elements starting from 1 to the end of the array. And this shifting of the element actually insert a lot of inefficiency in this dequeuing operation. The actual dequeuing operation is taking place only in these two lines of codes, but just because for array you need to maintain contiguous or consecutive memory location, you have to do all these shift. So this is basically a point of inefficiency in this array based implementation of dequeue operation, and this type of inefficiencies can be eliminated if we use linked list based implementation instead of array. And in the next few videos, we are going to see that.